Hello everyone. In this lecture, let us discuss about the addressing modes of 8086. What is meant by addressing modes? The way how an operand is specified in an instruction is known as addressing modes. So whenever we are writing a program, in an instruction, we will be using various operands to perform different arithmetic and logical operations. So we have the mnemonics, so the instructions, and in the instructions, we'll be mentioning the operands. The way how we represent the operand is known as addressing mode. Addressing modes specify the way how to access the variables, arrays, pointers, and other complex data types too. 8086 has 12 different types of addressing modes. Here are the addressing modes: immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, register relative addressing mode, base index addressing mode, relative base index addressing mode, intra-segment direct mode addressing mode, intra-segment indirect mode addressing mode, inter-segment direct addressing mode, inter-segment indirect addressing mode. In this lecture, let us discuss the basic addressing modes. The first one is immediate addressing mode. In this addressing mode, the data can be specified as a part of instruction. So if we see these examples, this is the instruction, the mnemonic, and these are the datas. Here the data 03, which has to be moved to the register CL, is being mentioned in the instruction itself. So the operand forms the part of the instruction in immediate addressing mode. So this is 8-bit and this is 16-bit. Example for 8-bit and this is the example for 16-bit. If you are using 8-bit, we will be using CL, CH or other A, B, C, D, H and L registers. If it is 16-bit, we will be using X registers. Next is direct addressing mode. In direct addressing mode, the 16-bit memory address is directly specified in the instruction as a part of it. So if we see here 5000, since it is mentioned inside a square bracket, it means that it is an address. So this address is directly mentioned in the instruction itself, which is known as the direct addressing mode. So how will we calculate the effective address? So the data segment address plus this forms the effective address. Next is register addressing mode. In register addressing mode, the register is directly mentioned in the instruction. See AX and BX. So in 8086, 4 general purpose registers are there: AX, BX, CX and DX. All these 4 are 16-bit registers. Or we can mention these as AL, AH, BL, BH, CL, CH and DL, DH, each 8-bit registers. So 8086 has 8 8-bit registers or 4 16-bit registers. So if we are using 16-bit registers, we will be mentioning it as X. So move BX, AX. Here this AX as well as BX are registers. So registers are directly given in the instruction and so this is known as register addressing mode. Next is register indirect addressing mode. In register indirect addressing mode, AX and BX are registers. So this register BX is indirectly specified in this instruction. That is, the data in BX will not be accessed, the data in BX, the effective address will not be BX. The effective address will be BX added with the data segment register address, and then the data in that address will be transferred to AX. So if it is register addressing mode, the data in BX will be transferred to AX. In register indirect addressing mode, the address specified by the register BX will be having the operand. So BX will not have the operand. BX will specify an address, and that address will be having the operand. This is register indirect addressing mode. Next is indexed addressing mode. In indexed addressing mode, the index register forms a part of the instruction. The offset of the operand is stored in one of the index registers. DS and ES, that is data segment register and extra segment registers, are the default segment registers when we are using index registers. So index registers are mentioned in the instruction in the case of indexed addressing mode. Register relative addressing mode. In register relative addressing mode, see here BX is a register and the relative value 50 is being used. So when an effective address is being calculated, the BX is added with this relative value, or this is a displacement value, and then that will be added with a data segment register in order to find the effective address. So here the relative value or a displacement value will be there in the case of register relative addressing mode. Next is base indexed addressing mode. So here in this case, here we have the effective address of the data is formed by adding the contents of the base register to the contents of the index register. So this base register is being added with the contents of the index register, either SI or DI or SI registers, and then effective address has been formed. So SI added with BX along added with DS forms the effective address. Next is the relative base indexed addressing mode. Here, the effective address is formed by adding an 8-bit or 16-bit displacement or with the sum of contents of any of the base register and any of the index register. So, SI is added with BX, is added with the base DS along with this displacement of or offset value in the case of relative base indexed addressing mode. So we have, out of the 12 addressing modes, we have discussed the most important and the basic addressing modes. So this is an assessment for you. So the source index register is being mentioned and the contents of DA register is also mentioned. What will be the effective address? So can you guess? So SI will be added. Similarly, another assessment is for you. How the effective addresses are being calculated. I hope you have enjoyed the session. Thank you.